So I'm going to cover design automation here. We spoke a lot about CAD and data management, or a little bit of data management, but there's some really advanced capabilities that we have that we can automate a lot of the engineering work. So, you know, traditionally engineers, as myself, used to work. I would sit there, design something and test it and do this and do that, whereas now I can actually put in some parameters and have a model design come up itself. So, you know, we'll go into how do we automate these design and the process itself. So, how do we solve customer issues? We make parts, we make assemblies, we make drawings, and we go to manufacturing, and we have a solution, right? We can do I-parts, intelligent assemblies, where it has, let's say, specific behavior, where you can manipulate its sizing and so on within Inventor. But we're still not solving a lot of the customer issues today. Within Inventor, we have iLogic, where we can set up, you know, basically an API or an interface where you can program, you know, some rules of how this model needs to, you know, change in size or even property or materials. Has anyone heard of Configurator 360? This is where we take a CAD model in Inventor, and we can put that up into the cloud with all the parameters to allow somebody to go in and say, okay, I want the length to be so-and-so, the height to be in so-and-so. The model would then update itself along with the bill of materials, and then you can actually send that down as in a step file, another Inventor file, CATIA file, SOLIDWORKS file, PDF file, whatever file you need to pass on to your department or your customer. But ultimately, we solve these issues using Inventor ETO. ETO is engineer to order, and I'll talk about that throughout the session. So in the design landscape, we have the very extreme, you know, one item, one design that's probably going to go to the moon and, you know, maybe not come back. So this here is obviously a robotic sort of machinery that needs to operate in different conditions, not known to Earth. And we only make maybe one or two of these every maybe 10, 15, 20 years. Everyone's got a laptop now, I think. There's millions and millions, hundreds of millions of these that are being produced versus one, right? Then you have in the 50% range where there's only about 1,000 of these units being produced maybe on a yearly basis, okay? It's not mass production, right? It's a very niche market, very specific to an industry. And, you know, and 50% means that 50% is standard design and 50% is configurable. Customer may want this in a smaller size or a bigger size, but there are a lot of standard sort of design considerations being taken in. This is one design off a line, right? You've got a jet fighter sort of plane where 75% of it is actually custom and 25% of it is actually standard. And they only produce maybe 100 of these. Then you've got the likes of you know, manufacturers that are into small sort of component level design equipment, you know, fans, where you have, let's say, 75% standard and 25% custom. So the only change in here is the actual scale or the size. So the engineering to order versus configure to order, okay? That's the difference here, and this is what I'm going to actually go into, okay? So this is the spot that we will address and further automate or engineer to order companies. We won't go in and give a solution to the guys that make a few components, or these IT manufacturers. So you have a customer, and from there, right, there's a couple stages during the actual custom product sale interaction. When business is won, right, through a bid process or a bid response, then the actual development for that custom product begins. And how does that begin? It begins in two areas. You've got the design and sales automation side of things, right? Of course, design being the CAD, the information, and the manufacturing behind that product. But what ends up happening, I'll just put this down. So under the design automation, right, we use Inventor, okay? And then on top of Inventor, we have something called Inventor ETO, Engineer to Order Series, which is basically, it's not a separate installation, but this ETO sits on top of the actual Inventor. So Inventor ETO is Inventor. You can design, you can do anything you like, okay, as in general design CAD approach. But the actual design automation, where it comes in, is we capture the requirements by saying, okay, well, we have a product. It's got a certain configuration or certain size. There's 5 different materials that I want to be able to select. This is the range that I want it in, from 50 millimeters to 500 millimeters. So you set some rules or some boundaries, and then we capture that and we put it into the actual Inventor, which we can populate an interface where these requirements that are captured into a product configuration. So instead of going in and saying, okay, now I need to draw a circle, I need to dimension it, I need to apply 50 mm, and I need to extrude it, and then apply another feature. You basically want to create a shaft. And within the product configuration, you actually design your model based off a table. So you have shaft size, length, and so on, and material. By inputting some values and selecting, let's say, a property or material, next to that, you'll have the actual 3D model come up on its own. And again, there are ranges that you set. So if you're under a certain range, it'll flag up and say, hey, you're not in that range. You need to be within 50 to 500. So you can set those boundaries to play with. But then where does sales automation come in? It's still the ETO plus the Configure 360, which allows you to be a little more mobile, to kind of take your products out into the market and showcase that. So what does that do? That takes what you've done here and put a cost against it. And against the bill of materials that you're producing out of that ETO, as well as sending out a proposal document to your customer with a drawing, a bill of material structure, and basically a price to go with that. All automated. So we spoke about 2D earlier. To design stuff like this can take a week, 2 weeks, 3 weeks, depending on how complex you're designing. 3D design seems to be the standards now of the companies, of what they're using. It still takes a bit of time, right? So for someone to learn it, to use it, to become very, very good at it. And then you have iLogic, which you can set up some rules to maybe save a bit of time on some repetitive tasks, okay? And then you have ETO. You basically put in information related to this component, and this product is actually created in a model with all the deliverables and documentation that you need. That's automation. That's in minutes. So that's the key difference. So I'll talk about these further in. We'll see some videos. Hopefully they work. So these are automated engineering tasks. So when you ask yourself, right? How do I take advantage of this software? What was it? Why would I need such an engineer to order sort of approach or product, right? Basically, the actual calculations, the requirements, any rules of the industry that you abide by need to be captured into here. And then once these are captured, right, these are the customer's needs, and going forward is what he wants to control. So no designers making any human errors, designing outside of the context of the actual requirements. I will skip this. Okay, so what is our strategy? So not only desktop application, but also cloud. So we want to merge these two together by providing the desktop users access to the cloud to do more. And how do we do more? Through the Autodesk 360 services. So if you're a customer of Autodesk, you have subscribed to our products. You have access to the A360 account, which is free. And from there, you actually can use the Inventor Design Optimization. Has anyone used this? Inventor Optimization? Yeah, okay. So just a quick one on that. So if you've got, so optimization is FEA. So you take a product, and what you want to do is you want to test it based on a load or a force. I want to apply a certain amount of force, but I have this part, it's got this material, it's got this thickness, it's got this length. I want to know what is the optimal thickness, length, and material for that part. So I can set up a thickness of 12 mm, 10 mm, 14 mm, 15 mm, and I can set up 3 different lengths. I can send this to the cloud. It'll come back and notify me that your 10 mm with a 300 mm long is your optimal design according to the safety factor you've set out based on that force or that load. So this is something really to take advantage of, because traditionally in FEA you would have to bring in every CAD model or set up every calculation based on the different parameters or lengths or thicknesses, and then you would have to compare these. So this actually reports out in a document what is the best solution. And then we'll go into 360, where I'll talk about that, and Mockup 360. Has anyone heard of Mockup? No? Okay. So we'll talk about these two. I mentioned a few things on that, all right? So just a quick one on 360, right? It's to kind of centralize, bring everybody together to collaborate, share, their projects, and communicate, whether it's email, to include their meetings, upload their drawings, models, videos, documents outside of the Autodesk environment, and so on. So just a quick interface. This is the Autodesk 360 dashboard. Along that, you'll find a few sort of main areas. You've got the projects that you're, working on, and within that, all these projects kind of are listed according to what you and the other members of that project team are working on. Then you've got the project view, which is kind of further down. So when you open up a project, you'll find all the team members that are part of the project, any latest information that's been uploaded, any comments, any file sharing, that's being communicated throughout the project itself. And if you drill down further, you can start to go into the data, individual data of that project. Whether it's a picture, a sketch, a video, whatever relevant information helps support that project. And mock-up. So today, we have basically a product that's come out to allow customers, the OEMs, and the suppliers to communicate together. And all of them are using different platforms, different communication of products. And mock-up is something that actually creates a single environment where everybody can log on, come inside to this environment, and bring their information in, and build and work on a model. So right here is a good example. So you bring, through that, you work on a part or component, you add that to the mockup, that gets uploaded, right? You're running in the web. I have users, that are supplying components in NX, Creo, Dassault, CATIA, and so on. So you can have individual sub-assemblies that can be uploaded, and everybody's working on the same information in one environment, regardless of what CAD you're using. Okay, I'll show you this. This is how you can upload this model into the mock-up environment. So this is a food and beverage sort of process line. You can bring it in. You've got the history. You can do section views. You can sort of comment, on the actual design, share it with the people that are working with you. So this is another way to collaborate outside of the company with other users, other engineers, other suppliers. And what's cool about this is you can actually take this complete model and say, okay, now I need a second production line or a third production line, and you can start to build this out. So, it's very lightweight. It doesn't take a lot of RAM and sort of a high capacity desktop to run such a CAD model. So the Configurator 360, so this is where the engineers, the sales, and the customers can download information. This information actually comes from the manufacturer. They would, excuse me, they would design something, right? And they would publish it. They would take this product, this VMech unit, and they would put it up into the Configurator 360, and then the consumers can then configure it and say, well, you know what? I want it in this style or this size or this shape or this color or this material. They can configure it, download it with a quotation and say, okay, well, this is basically what it's going to cost me. And I'll show you a quick video on this. And again, it runs in various internet applications. And I think there's a video coming up. Okay, so I'll just get into this video here. Okay, so we're just testing out the range of this unit here. And we can automate some tasks by, the iLogic. And we can upload iLogic intelligent information into the Configurator 360, right? So whatever the forms that you've added here, pertaining to the crane can also be published out into the configurator. So what you're doing here is you're actually capturing, okay, what do I want this interface to be? How do I want to control this? Instead of going back into the actual sketch or the actual part model and changing the feature to give you a range or an automated result, you capture these ranges, right? Or the motion or the capacities of it inside this form. So this is an Inventor. This isn't ETO. This is just purely iLogic, which comes with Inventor that sits inside. So from there, you set the minimum values, the maximum values of how you want your slider property or information to come out. Okay, and then you can even add a picture in, link it back to your project data or even, a file that's actually stored inside the vault. And then when you actually create the actual form, you can start to drive and automate your design just based on a few things that you want to see or you're concerned with or you're interested in. And that represents, what we're looking at inside the environment here. So, and this is basically, automated, an automated approach. There's another quick one. This is, the trailer. And again, same thing. You capture what you want to drive, and then based on the rules, you can, it'll populate some certain support, bars and so on. Now you've created, this model. You've uploaded it into the Configurator 360. You bring it in. You're also able to control the different parameters of its heights and widths and so on. And then as you can see down here, you can publish that out into a PDF, a DWG, and this is basically the outcome, right? You can get, drawing section views, whatever it is that you would set up. You can also access this through the mobile sort of app. You log onto the iPad, and again, similar functionality. You can change and update, your configuration. You can request a quote, and then you would have a document generated after that. Is that it? Okay, just to highlight some of the customers, and not limited to this, I've only selected a few of these customers. Parker Hannifin, Cameron. Cameron does pressure vessel tanks, so big, huge tanks for the industrial applications, for oil and gas and so on. And instead of drawing every single tank, they basically come up with, a configured sort of window interface that we helped them with, and then they would enter all this information, and then you would have this tank build itself, and then whether you want a second section, a third section, and a fourth section of the tank, that gets automatically populated. From there, the automatic deliverables like the drawings, the bill of materials, even connecting that into the ERP system is by a push of a button. So the engineering time has gone from weeks to probably a few minutes, and you're getting, results into the purchasing department within, less than an hour, I would say, with 100% accuracy of data. So it's across the board. I mean, we've got, manufacturers of pumps, heat exchangers, GE Healthcare is a good customer of ours that we've helped. So there's quite a few different applications this can be used for. So just keep in mind that if it's something that's about the 75-25 rule, where 75% of it is configured, 25% is standard, then we can go ahead and help you automate these a little quicker. So I did say I was going to finish it in 5 minutes. Thank you. Any questions?